The Plasticizer Controversy. My name is Zoe Harfield, and in this video I'll be talking about plasticizers and the uproar they have caused, particularly in relation to the manufacture of children's toys. First, a quick recap on polymers seems in order. You'll remember that polymers are long chains of mainly carbon atoms and consist of smaller repeating units called monomers. There are two main types of polymerization to form synthetic polymers: chain growth, where monomers are added one by one to the reactive end of a growing chain, and step growth, where monomers join together via their reactive groups, getting exponentially longer as larger collections of monomers join together. If we take PVC pictured here, it can be made via free radical polymerization, which is a type of chain growth polymerization. What are plasticizers? Though you may not be familiar with them, plasticizers are everywhere. 90% of them are used to produce PVC, which you can find in your flooring, roofing, wall coverings, medical devices, plastic bags, and much more. Plasticizers are low molecular weight polymers that are embedded between individual polymer chains, increasing the spacing and allowing the chains to slide against each other as the interchain London dispersion forces are disrupted. Now, what does that mean? You'll remember that polymers themselves consist of long chains of mainly carbon atoms, arranged and held together by polymer-polymer interactions between the chains. Factors such as chain length and branching can affect the strength of these interactions, and their resulting properties of strength, stiffness, hardness, etc. When plasticizer molecules arrange themselves between the chains, the flexibility and toughness of the polymer is increased as the plasticizers force the chains further apart, increasing the free volume, reducing their forces of attraction. Another factor at play here is the glass transition temperature, which measures chain mobility. Take, for example, if you've ever left plastic objects, such as a plastic bucket, outside in the winter. You would have noticed that it's more rigid and brittle, and cracks more easily. This is because it's in its glassy state. This is below its glass transition temperature. Above this temperature, the plastic will be in its rubbery state, where they are more flexible. Plasticizers lower the glass transition state of polymers, as the polymer chains are more mobile at lower temperatures than they would ordinarily be, and they are thus softer and more flexible. This is a unique and useful property to polymers. So, plasticizers are used selectively to make a certain polymer more suitable for a certain application, as there are some cases when a plastic needs to be more rigid, such as for piping, and others when it needs to be more flexible, such as for vinyl flooring. Phthalates are the esters of phthalic acid. There are many different types of phthalates, but the most common, and later you will understand the most controversial, is DEHP. DEHP, or di-2-ethyl-hexyl phthalate, has the chemical formula of C24H38O4 and is used in various PVC products such as medical IV and blood bags, furniture materials such as upholstery and mattresses, cosmetics, and also children's toys and infant care products. Due to its overuse, it is ubiquitous and widely distributed throughout the environment, and can metabolize in the body. DBP is another common phthalate, also known as dibutyl phthalate, used largely in PVC, but also in inks and cosmetics. Throughout the globe each year, more than 18 billion pounds of phthalates are produced. Phthalates are understandably very useful in industry, with PVC in particular being such an important material in the manufacture of a variety of staples. Yet they are also a subject of controversy. Looking online, you can find countless headlines on the supposed adverse health effects of phthalates, such as increased risk of postpartum depression, decreased fertility in men, and impaired neurological development. But what has been of serious concern is their suspected effect on young children, and what may have led to the ban of key phthalates, mainly DEHP, DBP, and BBP, in children's plastic toys. This is what I'll be focusing on in this video. Why are toys in particular provoking such concern? The phthalate plasticizers used in PVC toys are not bound to the polymeric matrix, so they could in theory migrate out of the plastic and be ingested by, for example, the sucking and biting action of babies and infants. Prolonged exposure to, or ingestion of phthalates, such as DEHP, has been the subject of research. There are various reports debating the validity of health concerns on the toxicity of phthalates, but in a nutshell, interestingly, it starts with rodents. Prolonged exposure of rodents during gestation to DEHP via oral doses results in adverse effects on fetal development, structural changes in the testes, reduced fertility, and altered sperm measures. However, making judgments across species is difficult, and there are fewer studies on the effects of phthalates on humans. Rodents, for example, have higher levels of intestinal lipases, which results in higher absorption of DEHP than would occur in primates or humans. Primates show no testes effects when exposed to DEHP at oral doses similar to those which would cause testicular toxicity in juvenile rodents. Thus, we can infer that there is minimal concern that ambient human exposures would adversely affect adult human reproduction. But adults are more efficient at metabolizing DEHP than children under 6 months. Experts express concern for the effects of ambient or greater phthalate exposure on infants and toddlers whose reproductive systems are still developing. Like many things, however, much is up for debate. For example, it must be noted that it's incredibly difficult to make inferences from animal data about the effects on humans. Another study also determined that the migration rates of DEHP from PVC is very low until high temperatures or in the presence of oily or fatty substances. There are also an assortment of other adverse health effects associated with DEHP, which I have not gone into detail about in this video. So what can we expect next? From a public health perspective, additional data on the levels of specific phthalates in toys and better estimates on salivary extracts of phthalates commonly used in toys, such as DEHP, needs to be gathered, as well as direct studies on the potential developmental effects which may occur when pregnant women and infants are exposed to phthalates. We can then possess the necessary knowledge to put limitations in place on phthalate usage in other departments, such as in infant care products, if the science agrees. Furthermore, certain expert panels have expressed greater concern that exposures of critically ill male infants who are exposed via medical therapy can approach doses that are toxic in rodent models. Therefore, such exposure may be of serious risk to the male reproductive tract development. A 2001 report claimed that DEHP concentrations in medical tubing could be as high as 80%, compared to the 1 to 40% generally used in other products. It's possible that further measures are necessary to be limiting exposure to phthalates for young children in other fields, rather than solely in plastic toys. Otherwise, it seems that other plastics have begun to replace PVC, such as PET. However, there has been very little research on the health effects associated with PET to determine whether it's an acceptable replacement. Research on the migration rates of antimony trioxide, which is a potential toxin present in PET, shows that it exhibits greater migration rates and at lower temperatures than DEHP for PVC, possibly because it's often left near the surface of the plastic following manufacture. Alternative plasticizers are also in use, such as isosorbide diesters, ESBO, and COMGHA. Here you'll find a list of references in case you want to look further into the topic. Thank you for listening.